Hi everyone, it's Miss Logan. Today I'll be talking about 1D motion vocabulary. Knowing this vocabulary is going to help us start off this unit and next unit, which will focus on 1D and 2D motion. It's expected that we know this vocabulary, so when we start our lab, we have some background when we're discussing different vocabulary terms. So most vocabulary that we'll be talking about will either be a scalar or vector quantity. So a scalar only has magnitude. An example of this is 3 meters per second or 5 miles. A vector, though, is a little bit different. It's going to have magnitude and direction. For instance, it may be 3 meters per second north or -5 meters. We'll often use plus and minuses, so positive and negative, to signify direction in physics. So let's apply scalar and vector to distance and displacement. So first, distance is the total distance traveled. This is like an odometer on your car. It's always counting up. We're going to use meters to describe this, and it's a scalar quantity, so direction in the sign does not matter. An example of this is if I start at 0 and I walk 5 meters and 5 meters back, my total distance is 10 meters. Now let's talk about displacement, which is a little bit different than distance. Displacement is the change in my position from the start to an end. I'm still going to use meters, but this is a vector quantity, so I'm going to have a direction. So an example of this would be I'm starting at 0, I'm going to 5, and coming back. My start and finish are in the same place, so my displacement is 0 meters. Another example of this, let's say I started at 0, and I walked all the way to -5, and I came back to -2. So -2 would be my ending point. Now let's think about this. The total distance I traveled all the way to 5 and back to 2, my distance would be 8 meters. But let's think about my displacement. The difference from the start to my end is only -2 meters. So we'll work with this during our labs and also using our position and time graphs. Alright, so let's think about this problem. You and your dog go on a walk to the park. On the way, your dog takes many side trips to chase squirrels or examine fire hydrants. When you arrive at the park, do you and your dog have the same displacement? Okay, so let's think about this for a minute. We might say that maybe our distance will be different. The dog is walking more, it's moving over to the side. But how about our displacement? Did we start and end in the same place? Yes, we did. So even though our distance can be different, our displacement can be the same. Okay, so let's talk about speed and velocity. So speed is the change in distance over the change in time. So this is a scalar quantity. We do not need a direction. We're going to use the symbol S for this and meters per second. Here's our equation, distance over time. Alright, so velocity is going to be a little bit different. It's the change in displacement over the change in time. Symbol we're going to use is V, and our SI unit is the same as speed, it's meters per second. However, this is a vector quantity. Why? Because we're using displacement rather than distance. The equation we're going to use is the displacement over time. So in some cases, yes, the top number for distance and displacement are going to be the same. However, we are going to have other cases where they are different, so it's especially important to remember our definitions for both distance and displacement when we are applying them. Okay, so acceleration is the change in velocity over the change in time. Because it's the change in velocity, it is also a vector quantity. We're going to use the symbol A, and our unit is meters per second squared. The equation we're going to be using is the change in velocity over change in time. Don't forget, our triangle symbol means change. That's in all sciences, we use that to represent it. All right, so thank you for listening to this flipped lesson, going over the basic vocabulary for 1D motion. What you need to do right now is pause this video and answer these 4 follow-up questions. We'll be going over these questions in class, talking about our answers, and also any follow-up questions you have specifically on this video. You may be wondering why we're not solving any problems using our equations. That's because we'll be jumping into graphing position, time, and velocity to start out. Graphing is especially important for us to understand, and we'll be working on these equations for velocity, speed, and acceleration, along with other kinematics equations later on in this unit. So make sure you pause this video and answer these 4 questions in your notebook, so we'll go over when this video is due. Thank you.